Yes, it was quite difficult for me to actually define the scope for this talk because more people from academia are here than usual in my talks. Usually I'm used to give talks to in front of database administrators or kind of developers who are close to databases. But I decided to talk about the way how we scale Postgres and how we use SQL because I think this is a cool language and we have to somehow promote it and understanding how it works and kind of how can one use the system that is one of the best in this area can be quite interesting, I suppose. So yeah, that's me. I was leading database engineering team for quite a long time now. I'm head of database of data engineering. Yeah, that's enough. So Zalando, how many people here knows what Zalando is actually? Oh, so I can actually skip the whole set of slides. So we have so it's just some numbers. Yeah, every store, every online store is not just the nice kind of page. It is driven by something that is sometimes quite complicated. So we have very typical layout of our applications. We have services, and we are moving with a full speed towards the microservices. We have PostgreSQL database as the core storage for our data, and Solar clusters for implementing searching on the front ends. So some more numbers, something what can be interesting here is kind of we have more or less more than 100 database master instances, so that multiplies by the number of slaves and in different data centers. We have a lot of people working at Zalando already. It's 700 people. When I started at Zalando, it was only 50 5 years ago. It was one of the biggest growing companies in the world for some time. Yeah, it was quite interesting to see how we were managing to, and sometimes not managing to keep up with the growth. When I started at Zalando, it was growing 100% per month, and it was quite scary. So, and we still exist, so that means that we managed to kind of cope with this scale. So, we have not very big, but quite a big cluster of Postgreses. We have now 6 terabytes of Postgres data in our databases. Extracted our business event store database that is growing quite fast, and I have to update every time this slide because of this. Yes, yeah, biggest challenges: constantly growing, fast deployment cycles, no downtimes are tolerated, and actually the problem was that developers are used to stability of the systems, so they kind of don't write code that can handle database downtimes. So we had to keep databases running all the time. So now we are rolling into the direction of Scala and reactive and all this cool stuff. And I hope our developers will become more kind of, will write more resilient code so that database people will be able to restart databases much faster and much easier than now. For example, now to shut down the database, it's a whole preparation to do. So, and we are going into the direction of autonomous teams. So every team gets now autonomy to choose their technology, their language, their data storage. So kind of this is quite interesting and tricky, so we are looking how it will work out. So we are now rolling out this change, and this change is called Radical Agility at Zalando. So it will be quite interesting. So yeah, we'll probably hear about this in a year or something, if it flops or if it works well. So the scope of my, I already talked 6 minutes. I didn't want to talk so long. So the scope is to define how we access data, how we manage to change data models without downtimes in the Postgres, and how we actually shard our data and manage it to scale without limits. I call it without limits. So a typical access pattern, so typically, so what you have in more or less every commercial organization, you have some tree of objects. Kind of you have some domain of objects that are interconnected, and on the borders of these domains you have some links to other domains. But in most cases, if we see, for example, this customer and order hierarchy, then this is very typical for many organizations. So usually, not usually, but in 70s, the relational model raised, and it gave birth to relational databases, and the SQL was invented in our systems, I think, and this became the de facto standard to access and query your data in the databases. So the way how we access data and how we actually query data from our applications is usually masked and removed from the site of the developer by creating some object relational mappers. They have some advantages, of course, because the developers can stay in the in their comfort zones. They can develop business logic directly in the environment that they are used to develop business logic in. But there are some disadvantages of using ORM. For example, the transaction management can become a horror. You have to map everything that you have in the database into your application code, all the tables, and schema changes can become untrivial. There is another approach, the NoSQL approach. NoSQL approach actually says completely no to the relational model. Everything, the whole hierarchy is serialized in one document. There are advantages, of course. You don't need transactions. You serialize directly in your code, but there are some usually hidden problems. So implicit schemas are a horror, because when you start evolving your schema, the migrations can become quite complicated. All the migration code will come eventually in your business logic in the form of if case or some more horrible constructs. And of course, we have no SQL in these structures, so we cannot really easily query data that you store. So there are several alternatives. One alternative that, for example, Scala went and wrote wonderful ORM mapper like Slick. It's an impressive piece of code, and if you haven't seen it, just look into the source code. It's kind of mind-blowing. Clojure went into the direction of SQL, where they map directly SQL statements and allow you to access SQL statements as if they were functions. During the period when we were rolling out everything, we didn't have these technologies, so we were purely Java store. Actually, we were moving from PHP and Magento-based system to this 5 years ago to completely Java shop and Postgres-based. So we chose to go the direction of stored procedures. And there are several advantages of using stored procedures. So, for example, you can retrieve and send the complete object trees, like in NoSQL. You can you have very clear transaction scopes. You have very consistent data checks. So you move in all your data logic inside the store procedure, and you are close to your data, so you can really very easily operate it inside the store procedure using SQL. And you are not related to data schema, so you can migrate your data schemas and change the tables underneath your store procedure API without actually even telling, without the need to tell about it to the application logic. So this is a typical Java application. I'm talking about Java application because it's kind of, because I'm talking about Java here and what we did in the Java thing. So one can actually re-implement everything in some other languages. So the kind of this is what we did. So we kind of Java application, JDBC layer, and store procedure API. But we had a horrible problem. So the marshalling and extracting and sending data to store procedures was very difficult. So what we implemented was the Sprock wrapper. This this is more or less an RPC layer that makes the Postgres database your application server and exposes all store procedures as if they were Java store procedures. So just to demonstrate very fast, so you have the store procedure that inserts something, and then you define your interface with the kind of some annotations, and you define more or less everything that you need here, and the system automatically marshals everything in and out. This made it so easy that it's kind of now it is more or less piece of cake to write the mapper. So you can access your data using this kind of very small signature in your interface. You can actually use not only the store procedure, but directly the some kind of SQL query, and it will map everything up and down. But there are some, of course, disadvantages. Yeah, so CRUD operations for
to generate wrappers from the SQL code, or you just generate by hand both the SQL code?
Yeah, you just write this code. So because this is a very simple interface, the only thing that you have to write is this, more or less. Okay. And then you have the store procedure, and then it automatically maps it.
Thanks.
So it's not bootstrap. So some guys wrote the bootstrapper when they bootstrap the big kind of project. And write the set of store procedures, they wrote the bootstrappers, but it's kind of, it's needed only once, then you are not adding more store procedures all the time. Yeah. So yes, so developers can write bad SQL, and this is a big problem, and it's a very pity for me, because SQL is a very cool language. It's kind of it's a logical language. It has execution planner, it can do smart things, but developers don't like to write SQL, and I don't know why, but I suppose that in this room, people who are kind of more academia based, you all love SQL, and I shouldn't talk about this at all, but learning SQL, if you don't learn it, it will let you understand many things, especially in functional programming. So yes, advantages, use case driven, and yeah, horror stories. I usually put some horror stories, but I'm kind of out of time, more or less. Yeah, I will skip it. Another thing is that how we do versioning of the store procedures. You can think that kind of, okay, they have to put the store procedures all the time in the database. How do you version them? And we had this nightmare from the beginning, but then we came up with a very kind of, I think, smart idea that uses the feature of Postgres of search path. So you can actually set the search path in your connection, and every object that is being looked up in your system catalog is looked up in the order of the search path. In this case, for example, every object that is being looked up, including store procedures, is looked up first in this schema and then in the public schema. So you roll out this kind of tables in this schema, you use it, then you roll out another schema from another version. So it's kind of completely all store procedures together in parallel. You can actually test them separately without touching this area, and this is in production. And then roll out the kind of new version, test it, see that it works, then more or less remove the previous versions and kind of throw this garbage collect these things away if you are sure that you're not coming back. So this gave us really a huge speed because kind of the development of store procedures became as easy as development of Java code, I would say. But of course, it's not about problems. The kind of, the positive thing, tests are done to the whole API version, so there are no interdependency problems. No API migrations are needed, and deployments are completely automated. So the deployment tooling that we used is rolling out the new APIs completely independently from the kind of from the developers. So it's just takes the tag of the branch and names it like this. So, any questions so far? Yeah, so. Yes, the Postgres database is kind of very, I like it because it saved us a lot of problems, especially during the data migrations. And data migrations, we know that, for example, problems, it's not bashing, but it's kind of problems in MySQL led companies like Facebook to implement the whole new systems just to kind of, they couldn't extend the user table with a new column. And they had to kind of rewrite everything and to write a new kind of database for that. So they decided to do that. In Postgres, you don't have this kind of problems. You can more or less extend your data schemas without locks and without any problems by deployment, mostly. The number of full locks that you need in Postgres is becoming lower and lower with every new kind of release. What does it give us? The API layer, it can fill data on the fly. So for example, if you are kind of adding new column and it should be already pre-filled, you can pre-fill it in the store procedure and not update it somewhere in your kind of business logic up there in the application. We managed to several times to change the underlying data model completely without the application knowing it. So just by kind of changing the underlying store procedures. Yeah, this is about this, but I'm out of time for this, I think. Yeah, some more details about how we do the roll out the modal changes, because it's not so easy as store procedures. You cannot just roll out new tables every release and kind of forget about the previous data. So we kind of have some format. It's probably not so important, but it's just a small diff file. I call it diff file because from the beginning we were writing determining the difference between two schemas in development database and the production database, and generating these things by hand, automatically. But it was not so good idea. But the name, so we didn't manage to do this, but the name stayed, and this things are generated by people themselves who are changing the models. Yes, as a kind of interesting thing, interesting fact, we didn't have a single downtime of the system, kind of that was due to problems with migrations. So, and I think this is quite an interesting fact that you can operate relational database, doing a lot of changes in the data models. For understanding, we do up to 100 data model changes. So we have up to 100 diff files per week. So it's kind of, we have weekly release, and we are managing to kind of, developers are not limited by the fact that they're using relational database. And this is something that is quite difficult to achieve with old style systems like Oracle, for example, where they have to log quite much more during the updates, during the migrations. And you can imagine that the actually it's quite fluid, the whole kind of data structures. So from the beginning, in the database team was trying to control the database models much more than we could actually. But then we understood that with growing number of developers, it's not possible. So we were doing SQL trainings. We teach our developers how to write SQL and how to write kind of this change files, and this helps a lot. So yes, and probably the most interesting thing, kind of how do we actually shard our data. So the problem with the advantages of big database, one big database, is very difficult to not to see, because if you have all your data in your one database, then you can access all data, you can correlate all the data. It's wonderful for business intelligence. It's very simple access strategy, and I don't recommend to anybody to split your data away into several databases if you don't have to do it, because it's kind of, it's so much wonderful, so much fun to have it in one database. But unfortunately, when data doesn't fit into memory anymore, then you have usually a problem, because you are starting to hit the bottleneck of the input-output performance. You need much longer times for migration tasks. You may need much kind of more expertise in operating such a big database. Yeah, this is poor Postgres. So what we do, we actually we shard our databases. So sharding gives us the possibility to still make the data fit into the memory. It widens the I/O bottleneck, and kind of all the negative things that I mentioned before kind of are gone with a smaller database. But yeah.
What does OLTP mean? OLTP.
Oh, I should have looked it up. I'm still online transaction.
Processing.
Yeah, online transaction processing. Yeah. I'm using these terms for years now without kind of really knowing the what the abbreviation means. Thank you. So yes, and the disadvantages of sharding is that you cannot join objects that are located in different shards, of course. So it's kind of, if they are located physically on different machines. And that brings you to the situation where you need much more tooling to kind of to operate such a system. So one kind of a tooling would be to move everything to Cassandra, because Cassandra is kind of a system that actually provides you with the tooling that does it. But unfortunately, Cassandra is still not yet quite as SQL database as, for example, Postgres. And in the times when we kind of were thinking about how we will be solving these issues, Cassandra was a very kind of not very advanced system. But Cassandra is a very cool thing, so one should definitely kind of use it. But we had stored procedures. We had the possibility to access data we had already the layer with this Sprock wrapper. So what we did, we extended Sprock wrapper and Sprock wrapper can now access kind of parallel databases. So it's really very easy, and the only thing that you have to do is more or less is to define which key that you use is your partitioning key. Knowing the partitioning key, the Sprock wrapper can use the defined sharding strategy class and more or less pre-calculate to which shard it should go. We implemented several lookup strategies like searching on all shards in parallel, for example. If you don't know the
Just a question, how big is one shard approximately?
We thought that we will keep them less than 100 gigabyte, but now our biggest shards in 16 shard cluster is something like 1 terabyte or something. But it's difficult to say what is the size because I'm
Just
saying that
So you have 1 terabyte now?
It's 60. So on one of the biggest clusters, we have kind of 16 shards, and every shard is I think it's half a terabyte or something like this. Yeah. So I'm. It's working so fine that I even don't know how it how big the databases are. Yes, so hash lookups and unique shard, so shard-aware IDs. So the shard-aware IDs, we more or less used the idea from Tumblr, and we use MD5 hashes of a partition key to extract the to calculate just the bit number, and then we use, if you have 2 shards, then you use the first bit to address it. If you use 4 shards, then 2 bits. But the advantage of this thing is that your data is completely pre-sharded. So you can every time split your shard and just change the strategy to use one another bit, and then you have 2 times more shards that you can use already. And you don't need to move any objects between the shards. So the only thing that you have to do is to delete the objects that are not anymore addressable by this strategy. Yes, additional thing that we are now working on is the new feature in Postgres that is a logical replication, and we are working on using this feature. What we want to do is to no, I forgot the slide. What we are working on is a project Saiki, is also open sourced on our GitHub. We decode the logical replication stream from all the Postgres databases, push them into the queue system, and then decode them back into different systems. So now we have drivers for Postgres, so we can extract all the changes from all the databases and put them into one big Postgres database, for example, or to Cassandra or to Oracle. So this makes it even much more interesting from the point of view of accessibility of data, and especially in the context of in the context of microservices and teams that are kind of keeping their own data for themselves and not giving access to the databases to other teams. So we need to somehow be able to extract data from there, from this remote databases, so to say, and to collect this data back somewhere in for business intelligence and business and data science people. Of course, so we also are moving away from our data centers to AWS. That we hope that it will give us more flexibility in building up services. And there, we have another project that is a kind of high availability appliance for Postgres, where we are using our framework for AWS to bootstrap Postgres databases inside AWS. Yeah. So, do we have time? Actually, other slides are more about kind of tools that we built for the infrastructure. So, any questions so far? Yep.
I have two questions about sharding. I don't understand what is partitioning key. What are you using for it?
Yep.
And do you have some problems or tasks connected with join on this sharded databases?
As I said, it's not so easy to join between the shards. So usually you try to put your objects so that they don't have anything to do with each other. So, for example, customer information. Yeah, so customer and its orders, they all have to be located on one shard, and customer 2 and her orders could be located on another shard. So if you manage to define these domains of objects that are related to each other, and use the partitioning, the unique key of the of the father of the root of the hierarchy as the partitioning key, then you are more or less safe in this case. Yeah. Did I answer your question? So the partitioning key is usually, in our case, is the customer number,
Okay.
or article or product ID, if you are sharding on products.
Let's say you have bad partition key, and will your system still work if, let's say, customer and orders of this customer somehow are in different databases?
I suppose that this could be caught by wonderful tests that our developers write. Okay. Yeah, because it's the problem with this thing is that it's a logical idea. Yeah, so it's kind of this partitioning key is nothing that is physical. Yeah, so it's a logical identifier that tells you that this set of objects should be collocated in one place. Yeah, so and the same idea would be kind of like with, for example, in NoSQL databases, you will also have some kind of document tree that you will aggregate together and put it into one kind of under one key. So this one key in NoSQL databases is the partitioning key in our case. Yeah, I can just kind of go through. So these are a lot of tools that we open sourced for monitoring, and so this is the list that I kind of compiled. Yeah.
One more thing, how many replicas do you have in your system?
The question was how many replicas do we have in our system? So usually we have, so as we had 2 data centers, we had 1 master and 1 slave in 1 data center, and 1 or 2 slaves in another data center. So the Postgres works like this, that it has a master kind of instance that accepts writes, and standby slaves that are accepting the write-ahead logs from the master. And the write-ahead logs are streamed kind of through the kind of inter-data center connect to the another data center and replay it there. So we always have a possibility to promote databases in another data center if we lose completely the first data center.
And how do you handle master failure?
The question is, how do we handle master failure? Master failure is handled by now semi-automatically. So we have tooling that allows us to kind of with 1 click to promote this slave to master. And this project is exactly this EVO project is exactly the idea there is that we will kind of completely automate the whole process. So it's kind of we are now experimenting with etcd console and actually with Zookeeper to use these systems to elect the master. And kind of this prototype works already, and we're now doing the experiments with the experiment with the storage systems in AWS. Of course, you can use the RDS in the AWS, but it's kind of they have already the support for slaves and so on. So it's kind of when we started, they didn't have it, and we need to apply very strict German auditing rules. So we have to stay in this concept in this scope of our STUPS infrastructure that is kind of infrastructure for, I would say, bigger companies to be able to roll out applications to AWS system, so that it's auditable, monitorable, traceable, and so on. Yes.
What are your thoughts on the newly introduced JSON-B data type?
Oh yes, I constantly forget to put this on the slides. So JSON data type was introduced already several years ago, and it was already used by guys in Heroku, for example, quite extensively for prototyping, especially the same way like you would use JSON inside MongoDB, for example. With JSON-B, there is there are wonderful advantages of kind of indexing of the JSON-B document and very fast access to it. So the at least on one node installation, this JSON-B outperforms Mongo, for example, I think 30 times or something like this. So and 95% of Mongo installations are single node installations. So and you still, with Postgres and JSON-B, you are still ACID compliant, and you still have all the advantages of and possibilities to split your JSON documents. When you know that your interface stabilized, you can actually split your JSON document into relations if you need it, or to keep it into.
You motivated the use of SQL because it's such a nice language for formulating queries to figure out some data. Yeah. That's one side of the coin. The other is, you just mentioned it, ACID. Which of the letters and how much do you use them?
Oh, now it's another tricky question about the meanings of the letters.
No, it's to simplify. How much do you use transactionality in general?
So we try to stay as transactional as possible. So at least we claim that we are completely ACID compliant. the kind of from our understanding. So where we could lose transactions would be during the situations where we promote the master and the application wouldn't kind of understand that we switched the we switched to a new master and go on writing to old master. So it's kind of these situations can lead to the partition. So network partitioning could lead to kind of anomalies that would lead to data failures or losing of the data. But we hope that this network partitioning, actually these problems exist for any system more or less, and having one master is quite a big advantage, so to say. So I think we are more or less ACID compliant. I don't know, did I answer your question, or?
Unfortunately, that's all the time we have, so thank you very much for.
Managing to keep up with the growth. When I started at Zalando, it was growing 100% per month, and it was quite scary. So, and we still exist, so that means that we managed to kind of cope with this scale. So, we have not very big, but quite a big cluster of Postgreses. We have now 6 terabytes of Postgres data in our databases. Extracted our business event store database that is growing quite fast, and I have to update every time this slide because of this. Yes, yeah, biggest challenges: constantly growing, fast deployment cycles, no downtimes are tolerated, and actually the problem was that developers are used to stability of the systems, so they kind of don't write code that can handle database downtimes. So we had to keep databases running all the time. So now we are rolling into the direction of Scala and reactive and all this cool stuff. And I hope our developers will become more kind of, will write more resilient code so that database people will be able to restart databases much faster and much easier than now, for example. Yes, it was quite difficult for me to actually define the scope for this talk because more people from academia are here than usual in my talks. Usually I'm used to give talks to in front of database administrators or kind of developers who are close to databases. But I decided to talk about the way how we scale Postgres and how we use SQL because I think this is a cool language and we have to somehow promote it and understanding how it works and kind of how can one use the system that is one of the best in this area can be quite interesting, I suppose. So yeah, that's me. I was leading database engineering team for quite a long time now. I'm head of database of data engineering. Yeah, that's enough. So Zalando, how many people here knows what Zalando is actually? Oh, so I can actually skip the whole set of slides. So we have so it just links to other domains. But in most cases, if we see, for example, this customer and order hierarchy, then this is very typical for many organizations. So usually not usually, but in 70s, the relational model raised and it gave birth to relational databases, and the SQL was invented in our systems, I think, and this became the de facto standard to access and query your data in the databases. The way how we access data and how we actually query data from our applications is usually masked and removed from the site of the developer by creating some object relational mappers. They have some advantages, of course, because the developers can stay in in their comfort zones. They can develop business logic directly in the environment that they are used to develop business logic in. But there are some disadvantages of using ORM. For example, the transaction now to shut down the database, it's a whole preparation to do. So, and we are going into the direction of autonomous teams. So every team gets now autonomy to choose their technology, their language, their data storage. So this is quite interesting and tricky. So we are looking how it will work out. So we are now rolling out this change, and this change is called Radical Agility at Zalando. So it will be quite interesting. So yeah, we'll probably hear about this in a year or something, if it flops or if it works well. So the scope of my, I already talked 6 minutes. I didn't want to talk so long. So the scope is to define how we access data, how we manage to change data models without downtimes in the Postgres, and how we actually shard our data and manage it to scale without limits. I call it without limits. So a typical access pattern, so typically, so what you have in more or less every commercial organization, you have some tree of objects. You have some domain of objects that are interconnected, and on the borders of these domains you have some numbers. Yeah, every store, every online store is not just the nice page. It is driven by something that is sometimes quite complicated. So we have very typical layout of our applications. We have services, and we are moving with a full speed towards the microservices. We have a PostgreSQL database as the core storage for our data, and Solar clusters for implementing searching on the front ends. So some more numbers, something what can be interesting here is we have more or less more than 100 database master instances, so that multiplies by the number of slaves and in different data centers. We have a lot of people working at Zalando already. It's 700 people. When I started at Zalando, it was only 50 5 years ago. It was one of the biggest growing companies in the world for some time. It was quite interesting to see how we were managing to, and sometimes not